This is a condensed version of my live stream from August 17th where we designed the laser targets for my trackless dark ride. If you like this condensed version, be sure to check out the full-length live stream and check out any future live streams I do by subscribing to this channel. So just like I said in the beginning in this title, today we're going to be working on laser targets. Targets for the ride with the laser gun. So basically the idea is I have these boxes here. These boxes are attached to power supplies, which go throughout the ride space. And then inside the box, there's going to be a Raspberry Pi Pico W, which can talk to the main control system over Wi-Fi. It has a power supply and a special radio module that you're going to have to watch my next video to find out why there's a radio module in here. But what we're talking about today is all these pin headers that are actually to go to laser targets. So then for laser targets, I have a bunch of boards that look a lot like this. So on this board, I have the IR, or I'm going to have an IR receiver module, just like we had in the laser gun video about the ride project. So I've got the IR receiver sits right in the middle. And then on the other three sides, there's going to be LEDs. These LEDs are actually RGB LEDs so that they can change color. And then I have a little bit of transistor driver tree circuit for the three LEDs since the Pico can't source that much current to drive all three LEDs at once out of its GPIO. All three of the LEDs can change between red, blue, and a purpley pink kind of color. So what I'm going to do is while you're riding the ride, the LEDs can change color, or maybe they'll be able to be programmed in such a way that when you shoot the target, you get a number of points based on what color the target is right when you hit it. And that way it adds a little more fun, and it's not just like sharpshooting, there's a little more strategy to the ride. Especially if it's not going to be as decorated as something like a Disney or a Universal ride, then this can add a lot more interest to the ride, having that little bit of strategy within the game. So what we're going to do in this live stream is we're going to design an enclosure for all the targets, a lot like these enclosures I've designed for the power supplies. So I'm going to first design an enclosure like that for these targets, and I actually want to make two different versions of the enclosure. One is just going to be round, and it can basically pinned up to the wall. And then the other will have a flat bottom so it can sit on the ground or on a table or something, just to give me a little more variety of where I can place the targets to make the ride a little more fun. So these are the enclosures for the microcontrollers and power supplies and radio modules, like we've already talked about. So there's the back plane, and then there's the bottom of the enclosure. Let's do this one. Bottom of the enclosure, and that's this box that I have here. So just like I said before, it's got the spot for the power jack, the opening for all the target wires, and then a spot to plug in the USB to the Raspberry Pi Pico without taking the whole thing out, so I can actually program them without taking it all apart. And then it's got a lid. I threw my logo on there just for fun, but what's actually most interesting about this lid is that it's a snap-on lid. So the way this system works is there's this little groove here on the lid which connects to this triangle spot right here on the box. And basically when you push the lid down, it spreads these walls out, and then they spring back in place to hold the lid on. And we can actually see that in action here. And if you just put it in and press fit, it snaps really loud, and then the lid's on the box. And it forms this really nice connection. So with that, let's kind of get into CADing. Now the only thing I've done here is I went into KiCad and exported a 3D model of the target PCB. And that PCB is just going to chill here, and it's going to be a reference for our design of the enclosure. I think I'm going to start with the with just like a base model for the target, for the enclosure, and then I'll branch it basically in order to make the one that gets pinned up to a wall and then the one that sits flat on the ground, a table, anything like that. So to start, I'll work in here. So I'll just do a sketch on the top plane, get some circles going, bop, bop, and let's measure this circle, it's 80. So we'll do like 82, and then this one needs to be 6 millimeters wider in diameter because it needs 3 extra on each side to make a 3 millimeter thick wall. So that's going to be 88. And then if I just extrude this outer wall by like 25 millimeters, should be fine. Then I'll come into the assembly just for fun, and let's insert these parts so we can kind of, look at them in reference to each other. So we have 2 parts here. And you know what? I'll just do, just for reference, I'll do like a fastened mate between here and here so that they're centered to each other. And we don't need this one. Yeah. So now that they're centered to each other, we kind of get the idea of how they sit with each other. And that 2 millimeter of rate of clearance on the side should be fine. So the last thing I'll do is I can actually come in here and do a, let's see, I just found this feature relatively recently and I really like it. I want to do edit in context. So this took me back to the Part Studio 1 where I made the walls, but it left me basically the PCB. It gives me a little bit of reference so I can kind of look at it and use it in context, so I can design the little struts here that are going to come out and screw down to this point. So what I want is a sketch along the bottom of here, and I will use this screw hole. Yep. Okay, and then I will make a and we'll make that like 8 mil. 8 mil should be good. And then I'll come out like this and like this. Then let's grab a tangent to make sure these are nice. Okay. And then I'll do a like 90-degree here. I guess what I really want to do is a construction line, and then I want a perpendicular from here to another one, Q. Let's get a tangent going from here to here. Oh. Yeah, let's get a tangent from here to here, and then a, let's see, perpendicular from here to here. There we go. And then I can get rid of these, and I'll do like a 45-degree angle here. So what this is this is just going to be a big, basically a big standoff to screw this target to. So if we look back at the full camera view, you can kind of imagine that this sits here, and then there's 3, that enclosure comes around like this, then there's 3 of those triangle bits that stick out, 1 for each of these screw holes I've left. So then if I come to the assembly, we can get rid of this fastened, we can kind of move this guy out a little bit, and then we can do a fastened mate from here to here. There we go, and that just kind of sits nicely there. So you can see what I meant by I don't need the back, because the PCB is already kind of acting like the back. So it screws down in these three corners here, but then I don't need to have a big sheet of plastic along the back because I have this PCB right here in the middle. Basically what we want is a lid that comes around like this. Gonna be a circle, but then it has all the rings of like your standard target that you'd see. So if we look up like a target, even in the target logo, it has these rings. So I want to replicate that, and half of them will be filled with black plastic, half of them will be open, and those open ones are to let the light from the LED come out. And then of course there'll be an open center for the IR light to come in and hit the IR sensor. This gets to be a new sketch along this face. Let's just clean this up a little bit. Then we'll do a circle. Let's just use this. We'll do a circle out to '88, and then we'll do another circle, but we want it to come in a lot more. Another circle. Did I miss? Yeah, I did. Okay, circle, 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 so full. Okay. Let's do this one to be like 78. That's not wide enough. Let's do 70. 55. 40. 25. What would that be? That would be 10. Let's do 57. 44. 29. 31. Then this one gets 2, 4, 6, 18. There we go. And then we'll do the same idea of having some basically we're going to want these struts to come through and actually hold them. And I'm putting these struts in line with the little standoffs because the LEDs I know are in the middle of the standoff. So these struts that are coming through are going to be not in the way of the LED as long as I make sure they're not they're above the standoffs. So let's do this again. There we go. And then we'll do, let's use this, use this, use this. Then we'll grab some construction lines from here to here. Line, construction, oh. Line, oh. Line, construction, line, construction, and then we'll get parallel to here, to here, to here, to here, from here to here. And then let's say we want them to be 8 millimeters wide, so 4 on each side. There we go. And I'll just do this on all 4 sides. All 3 of them. Oops. here to here, 4 millimeter, 4 millimeter, 4 millimeter. Okay. And now if we come and extrude this, we want this face, this face, this face, this face. There we go. And we only want this to be 3 millimeters thick, just like the walls. And then I didn't actually want that to be, I want that to be a new part. So now you can kind of see what I meant. The LEDs here give off light and hopefully illuminate the whole area. And then there's still this hole in the center for the IR sensor to sit on. Still plenty of room for the wire to come in. So that's looking pretty good to me. The only other thing I want to see is if we turn off this, keep the PCB, turn off this base. Just make sure there's no collisions here. It doesn't look like there are, so that's pretty good. So then, like I was saying before, what I really want to do is I want to have I have this base version of the enclosure, and then I want to make 2 versions. I want to make one that can hang on the wall, and then one that can mount or just be set down on a table. So wall mount's going to be pretty simple. Basically, all I want to do is I want to have the wire hang out the bottom. Here. I want to have the wire hang out the bottom like this. So it's just coming out straight out the bottom. And I'm just going to put a tab on the exact opposite side that can basically hold a push pin. I'm going to make it really simple with minimal damage to any walls. So I just do a new sketch off the back. Normal. Let's see. Yeah. Come off here, new sketch off the back, and then I'm gonna do bottom. Line through here just for reference, and I want this to here to be like a good 20 millimeters away. I'll give myself a nice circle to work off of, and then a line like that, and a line like that. And I'm basically just making the exact same thing as I had here. So I'll do a tangent, 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 and then I'll do 45, oops, let's do 25 degrees here. And then I'll dimension this to be like a nice 10 millimeter hole. Dimension this to be 25 degrees. I'll figure out the actual size I need for a push pin later, but this should be fine. Just chilling here for a moment. There we go. Then realistically, I think 20 was too much, so I'll just do like a 10 millimeters out here. There we go. So you can kind of see what I meant now. Basically, push pin goes in here, it hangs down, then the wire comes out the bottom, so there's not any weird torques put on by the weight of the wire. So that will be nice, just like that. And then for the floor mount, I want the wire to come out of the side and for there to be a nice flat part down here for it to sit on. So basically what I'm thinking for this one is I come to the normal, wire comes out the side. So I'll just do like this, like a Q, and then I'll do a up. And then I'll do another line to the other side, make sure it's horizontal. And then I will do like a 30 millimeter, like a 30 millimeter. Honestly, it can just come down like this to match the sides. And then I'll extrude that, both of these, add them in the opposite direction. Not blind, but up to face, and then the face will be this face. So now it has a nice side to sit on here, sit flat, with the wire coming out. This isn't part of the live stream, but I want to show you guys how they came out. Here's the wall mount version. You can see it has the tab that it hangs from and the PCB inside. And then here's the floor mount or table mount version. It'll sit upright like this usually. You can see the snap-on lids came out pretty well. If I shove a screwdriver in there, I can pull it off. There's my pretty little PCB in there, front and back. Thank you for watching this condensed version of my live stream. If you liked this, be sure to check out the full live stream with the link in the description, and subscribe to watch any future live streams I do.